NEC Section 240.21 B, titled Overcurrent Protection, states that each ungrounded conductor shall be protected in accordance with its ampacity from all sources. NEC Section 240.21 C, titled Location in Circuit, mandates that the overcurrent protective device shall be located at the point where the conductor receives its supply. Let's break this down further to understand how it applies to the scenario described. An 800 amp safety switch feeds a wireway, and from that wireway, two 400 amp main lug only, commonly abbreviated as MLO, panelboards are supplied. The question at hand revolves around whether these MLO panelboards constitute a code violation based on the requirements of NEC 240.21 B and C. To answer this, we need to analyze the specific requirements and their implications. Firstly, consider the ampacity of the conductors feeding the 400 amp panelboards. The conductors must be sized appropriately to handle the 400 amp load. NEC Article 310 provides guidance on conductor ampacity and is crucial to select conductors that meet or exceed the required ampacity based on the termination temperature ratings and other relevant factors. Secondly, evaluate where the overcurrent protection is located in the circuit. According to NEC 240.21, the overcurrent protective device must be at the point where the conductor receives its supply. In this configuration, the wireway is fed by the 800 amp safety switch, acting as the source of supply for the two 400 amp panelboards. Consequently, each of these panelboards must have its own overcurrent protection rated at 400 amps or lower if the conductors are sized for less than 400 amps. The critical point is that the MLO designation indicates that these panelboards do not have any main circuit breakers or fuses installed within them. An MLO panelboard is designed to receive power through lugs, and it relies on upstream overcurrent protection to protect the panelboard and the downstream circuits connected to it. Now let's address the code violation. Because the MLO panelboards do not have any overcurrent protection devices within them and are being supplied by a wireway fed by an 800 amp switch, they violate NEC 240.21 B and C. The conductors feeding the panelboards are not protected at their point of supply, as there's no overcurrent device located at the panelboard itself. The 800 amp safety switch protects the wireway but does not provide the required protection for the individual 400 amp panelboards. To rectify this situation and comply with the NEC, one of two approaches can be taken. One approach is to replace the MLO panelboards with panelboards that have main circuit breakers rated at 400 amps or less. This would provide the necessary overcurrent protection at the point of supply for each panelboard. 2. Install fuses within a fusible disconnect switch on each 400 amp panelboard feeder. This would provide the necessary overcurrent protection at the point of supply for each panelboard. It is imperative to remember that the overcurrent protection must be sized appropriately based on the ampacity of the conductors feeding the panelboards. Simply installing any 400 amp breaker without considering the conductor size would not necessarily comply with the code. For instance, if the conductors are rated for only 350 amps, the overcurrent protection should not exceed 350 amps, as outlined in NEC 240.4, which addresses the protection of conductors. Another important consideration is the interrupting rating of the overcurrent protection devices. The interrupting rating must be sufficient to handle the available fault current at the point of installation. This can be determined through a fault current study, which calculates the maximum amount of current that could flow during a short circuit condition. The overcurrent protection devices must have an interrupting rating equal to or greater than the calculated available fault current. Furthermore, the installation must comply with other relevant NEC articles such as those pertaining to grounding and bonding, conductor identification, and working clearances. Grounding and bonding ensure a safe path for fault current, while proper conductor identification helps prevent accidental contact with energized conductors. Working clearances provide adequate space for electricians to safely work on the equipment. In summary, The described configuration with MLO panelboards being fed from a wireway without individual overcurrent protection at the panelboards violates NEC 240.21 A and T. To comply with the code, the MLO panelboards must be replaced with panelboards that have main circuit breakers, or fuses and a fusible disconnect switch, or overcurrent protection must be added at each of the panelboards. This ensures that the conductors are properly protected at their point of supply, thereby enhancing electrical safety and minimizing the risk of overcurrent-related hazards. Always consult with a qualified electrical engineer or licensed electrician to ensure full compliance with the latest edition of the NEC and any applicable local codes. This configuration is not compliant because each panelboard requires its own overcurrent protection at the point where it receives its supply from the wireway. Since MLO panelboards lack built-in overcurrent protection, they violate NEC 240.21 A and T. This is because the 800 amp safety switch only protects the wireway and not the individual 400 amp panelboards connected to it. To correct this, you have two main options. 1. Replace the MLO panelboards with panelboards that include a 400 amp main circuit breaker, or 2. Install a 400 amp overcurrent protection device, such as a fuse disconnect switch, at the point where each panelboard connects to the wireway. The selection and installation of overcurrent protection devices must comply with NEC guidelines and local codes to ensure safety and proper operation of the electrical system. Now let's explore the implications of using conductors with different ampacities. If, for example, the conductors feeding one of the 400 amp MLO panelboards are only rated for 300 amps due to their size, insulation type, or ambient temperature conditions, then the overcurrent protection device protecting those conductors must be rated at 300 amps or less. NEC 240.4b permits the next higher standard overcurrent device rating if the conductor ampacity does not correspond to a standard size, but only up to 800 amps. This provision allows for slight adjustments to ensure proper protection without unnecessary nuisance tripping. Moving on, it's crucial to consider the interrupting rating of the overcurrent protection devices. The interrupting rating, measured in amps, indicates the maximum fault current that a circuit breaker or fuse can safely interrupt without failing catastrophically. The available fault current at the point where the overcurrent protection device is installed must be determined through a fault current study, which involves calculating the maximum amount of current that could flow during a short circuit condition. The overcurrent protection devices must have an interrupting rating equal to or greater than the calculated available fault current. Failure to properly assess the interrupting rating can lead to catastrophic equipment failure, posing significant safety risks. Furthermore, grounding and bonding play a critical role in ensuring electrical safety. Grounding provides a low impedance path for fault current to return to the source, allowing the overcurrent protection device to quickly trip and energize the circuit. Bonding ensures that all metallic parts of the electrical system are electrically connected, minimizing voltage differences and reducing the risk of electric shock. NEC Article 250 provides detailed requirements for grounding and bonding, and it's essential to comply with these requirements to maintain a safe electrical system. Now let's delve into conductor identification. NEC Article 310 specifies requirements for conductor identification, including color coding and marking. Proper conductor identification helps prevent accidental contact with energized conductors during maintenance or troubleshooting, reducing the risk of electric shock. Generally, grounded conductors must be identified with a white or gray color, while ungrounded conductors can be any color other than white, gray, or green. Equipment grounding conductors must be identified with a green color or a green color with one or more yellow stripes. Moving on, working clearances are essential for ensuring the safety of electricians and other qualified personnel who perform maintenance or repairs on electrical equipment. NEC Article 110 provides requirements for working clearances around electrical equipment, specifying minimum distances that must be maintained to allow for safe access and egress. These clearances vary depending on the voltage of the equipment and the presence of exposed live parts. Ensuring adequate working clearances is crucial for preventing accidental contact with energized conductors and facilitating safe work practices. In summary, the described configuration with MLO panelboards being fed from a wireway without individual overcurrent protection at the panelboards violates NEC 240.21 B and D. To comply with the code, the MLO panelboards must be replaced with panelboards that have main circuit breakers, or fuses and a fusible disconnect switch, or overcurrent protection must be added at each of the panelboards. This ensures that the conductors are properly protected at their point of supply, thereby enhancing electrical safety and minimizing the risk of overcurrent-related hazards. Always consult with a qualified electrical engineer or licensed electrician to ensure full compliance with the latest edition of the NEC and any applicable local codes. Let's also consider the scenario where the 800 amp safety switch is replaced with an 800 amp circuit breaker. Would this change the code compliance of the MLO panelboards? The answer is no. Replacing the safety switch with a circuit breaker does not negate the requirement for overcurrent protection at each of the 400 amp panelboards. The 800 amp circuit breaker still only protects the wireway and does not provide the necessary protection for the individual panelboards. Therefore, the MLO panelboards would still violate NEC 240.21 B and C. Now, let's consider the case where the conductors feeding the 400 amp panelboards are tapped from the wireway using tap rules. NEC 240.21b provides specific rules for tap conductors, allowing them to be connected to a feeder without overcurrent protection at the tap point under certain conditions. However, these tap rules typically require the tap conductors to be protected by an overcurrent device at their termination point, which would still necessitate overcurrent protection at each of the 400 amp panelboards. In most scenarios, the tap rules would not eliminate the need for overcurrent protection at the panelboards themselves.